friends, welcome to my channel. If you are watching my channel first time, please subscribe my channel. So in this video, we'll be discussing about complex numbers. So various aspects of complex numbers like how to find the phase of a complex number because complex numbers are represented with it has like real part and imaginary part. Now using that, if you want to calculate the phase, so what is the phase of a complex number is nothing but generally tan inverse of imaginary value by real value. If you say z equal to x plus jy is a complex number, then generally phase is given by tan inverse of y by x. This is what actually the formula. Now, so if you want to calculate directly, then we have direct functions for it in CMATH library. Now let us see first how to calculate the phase of a complex number. Okay, so for that we need to import first CMATH library. So I'll import CMATH CMATH. Okay, or else directly we can do with math library also. For example, math library. Okay, then let me define a complex number where z equal to 2 plus, let me say, 3j is what complex number. So here 2 is the real value and 3 is the imaginary value. Okay, now if I want to calculate it, what I have to do is tan inverse I took, right? So how to do that? math dot a tan is nothing but tan inverse of imaginary value, that is 3 by then 2 real value. This is what the formula is, and the phase is, the angle is this 0.9827. so if you want to get it in degrees, so math dot degrees function we have. Okay, so what I'll do is I'll just copy paste this here so that we'll be getting the answer in degrees, because that 0.9827 that is in radians. So now which is equal to 56.30. So the phase of this 2 plus 3j is this one. So like this we can calculate, but this is very long method. So directly, because we have CMATH function also, CMATH library also in Python. So let us make use of this, which will makes the calculation of phase very simple. So import CMATH I'll do. Now here directly here we have a function, like for example CMATH dot phase. So phase of which? Phase of a complex number z. So already we have defined that. Okay, if I ask this now, you see now I got same answer, that is 0.98. Okay, this is in radians. Now you can convert this value into degrees, or else directly you can say math dot degrees of, let me say, CMATH dot phase of z. So this also will work. So that also is giving 56.30. So within one line we can calculate like this. Okay, now let us change the input. So let me take z equal to, so let me say 0 minus 6j. This is what I will take. Okay, now so here I modified the z. So what I'll do is, let me execute the same thing once again. So that now z value is 0 minus 6j. Now I want to calculate it. So the phase is minus 90. That is correct, because this complex number whichever we have taken, it consists of only imaginary part, so and is also negative value, so negative phase, so that's why it's exactly at minus 90 degree. Okay, like this we can use we can find directly phase of any complex number using this particular function. And another things that are much useful are like converting a polar form to rectangular, because a complex number can be represented either using as a polar form or using a rectangular form. So now for example here we took, so let me take here z equal to 2 plus 3j. This is a polar form. Okay, this is a rectangular form, not a polar form. So polar form is one which will have only magnitude and angle. So here we got a rectangle form. Now directly I can convert into polar. So for example, we can use this function CMATH dot polar. So polar of z. So when I say polar of z, so that returns the magnitude and also phase value also. Okay, so for example you see here, so the magnitude is 3.60 and the phase is 0.98. That is correct now. Previously we have calculated the phase. Okay, this is what the polar equivalent of this. Now what let us do is, let us try to find its rectangular form. Okay, rectangular form is nothing but you can convert, you can take the coordinates in polar, then you can find out rectangular, means real value and imaginary value. For example, I'll use this function CMATH dot rect. We have this function called rectangular function, where I need to pass the magnitude first. For example, I want to pass 3.60555. The previous values only I'm taking it. Then the phase we need to pass in the radians, already. So any kind of angle, if you're passing into any function in Python you should consider only the value in radians, not in degrees. Okay, 98279 like this. Okay, so this is what I'm doing it. So now, so this is giving me 2 plus 3j, approximately it is 2.000, that is correct, and it is also 2.999, which is equal to approximately equal to 3. So that is what I got, 2 plus 3j as it is. So like this we can convert a complex number from polar to rectangular, also from rectangular to polar. Now let us try with something else. So let us take z1 equal to, as we took 0 minus 6j, let us take this number. Okay, now what I will do is I will convert first into polar. So CMATH dot polar of, let me say, z. Okay, now this is, the magnitude is 3.60 and the angle is this one, it is minus 90 degrees. It is actually, I need to use, it is actually z1, so this is wrong here. So here the variable is z1. So yeah, now it is, magnitude is 6 and angle is minus 1.57 radians. Okay, that is nothing but 90 degrees. Now let me check CMath dot, I want to convert the same thing into rectangular. I need to get back my original number. So I will say 6 comma then minus 1.57079. This is what I'll give as input now. Okay, so you see this, and what I'm getting is so it is 6 comma, yeah, so carefully observe it, it is 10 power 10 power, okay, it is 10 power minus 5, means 0.00003, it is approximately equal to 0. So real value is 0 and imaginary value is 5.99, means 6, it is negative minus. Okay, so means 6j. So I am getting my original number back. So why I am getting little deviation? Because I am not considering the entire values, all values I am not considering, because I considered only 4 digits after this particular thing and I ignored these digits. That's the reason why I didn't get exactly. I hope you understand this. So like this, so we can easily operate with the complex numbers using CMath library, simply like converting from polar to rectangular or rectangular to polar, or directly we can calculate from the face.